Now let's start with reactions of aldehydes and ketones. Pretty much all the reactions I talk about will refer to either aldehydes or ketones, no matter what examples I use. There are some that can just be done with aldehydes and some that can be done with ketones, but those will be specified in the following reactions. Start off with hydration. This is a reaction that can be done on either aldehydes or ketones, and what we're looking at here is turning a ketone or aldehyde into what's called a geminal diol, a gem diol, that is with an OH group, two OH groups attached to the same carbon atom. And we can have two possible mechanisms here, an acidic and a basic mechanism. And as I said earlier, these are the two mechanisms that will generally follow for aldehydes and ketones. And we're going to look at examples of both of these. Alright, so let's look at an example of the mechanism for the acidic one. In the first step, the H plus will attack the C double bond O. And that leaves a positive charge on the C, and the hydrogen will be connected to the H. The way I want you to look at this is we've got two electrons in this bond. One electron belongs to the C, one electron belongs to the O. Both electrons are used to form a bond between the O and the H, and that leaves this carbon short of an electron, so it's now got a positive charge on it. Now we can have the water come in and attack the C plus. We now have a bond from the C to the O, and then we can lose an H plus, and that gives us our product. Alright, so there we go. That's for the acidic mechanism. Let's look at the basic mechanism. The basic mechanism has the same product, but it goes via a different route. So the OH minus comes in and attacks this partially positively charged carbon here, and the electrons jump up on the oxygen. And we can get our product by having the O negative take an H off water, and that will give us our product. So we've got two mechanisms there for making these compounds. They're also called hydrates as well, and let me give you a little bit more information about hydrates. The mechanism itself is actually a reversible one, and in the case of a regular garden variety aldehyde or ketone, the equilibrium actually lies mostly on the side of the aldehyde or ketone, with the slight formation of the hydrate. But what we find is that if we change up some of the functional groups around the aldehyde or ketone, then we can get a greater possibility of forming the hydrate. And one of the ways of doing that is to put like something like 3 chlorine groups on the C that's next to the C double bond O. And what that does is it creates a pretty large partial positive charge on that C, and being next to the fairly large partial positive charge on the C in the aldehyde or ketone will end up causing a little bit of destabilization, so that when H3O plus is added, we get a much greater formation of the hydrate as opposed to the initial compound. This compound here is called chloral hydrate, and this compound here is called chloral hydrate. It's used as an anesthetic.